Hello, in this lecture we'll find out the length of line segment X using three different methods. In the drawing we have triangle ABC. Triangle ABC is a right triangle. Side AB of triangle ABC equals to 6 units. Side DC equals to 10 units. Angle ABC equals to 90 degrees. Angle DAC equals to 45 degrees. And we want to find out the length of line segment AD that is equal to X. So we'll start with the first method and we'll do a construction. We'll extend line segment AD by a straight line and from point C we will draw perpendicular to the extended AD. So this angle equals to 90 degrees according to our construction, and this angle is also equals to 90 degrees. We will define the touching point of the between the extended between the perpendicular from point C and the extended AD is point E. So actually we have here a right triangle, triangle AEC, and in the right triangle, triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, triangle AEC? We have here one angle that is equal to 45 degrees. We have also this angle that is a right angle, it is equal to 90 degrees. And we have the missing angle, angle ACE. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in a triangle is equal to 180 degrees. So here we will subtract 145 degrees from this equation and we get that the missing angle, angle ACE, is equal to 180 degrees minus 145 degrees is equal to 45 degrees. So we found out that this angle equals to 45 degrees. And we also have the rule that in front of equal angles in the triangle there are equal sides. So in triangle AEC we have those two angles that are equal to each other, they are both equal to 45 degrees. And according to the rule that in front of these equal angles there are equal sides, that is to say, we get that AE equals to EC. AE equals to EC, according to the rule that I mentioned. And we will define line segment DE as Y. So here AE is equal to X plus Y, so we can write here that AE equals to X plus Y. And from this equation, X plus Y equals to AE equals to EC, we will derive that EC is also equal to X plus Y. So we can write here that EC equals to X plus Y. And we also know that those two angles, they are equal to each other because according to the rule that vertex angles are equal to each other. So if this angle is alpha, then this angle will be also equal to alpha. And in the right triangle, triangle ABD, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle, triangle ABD to 180 degrees. So here we get that 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. Likewise, in the right triangle, triangle DEC, this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle DEC to 180 degrees. Okay, then we get that 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the reason that this angle equals to 90 degrees minus alpha. So actually we proved that those two right triangles are similar to each other. Why? Because all the angles in triangle ABD congruent to all the angles in triangle ADC. Those two angles, they are equal to alpha. Both of them, those two angles, they are equal to 90 degrees minus alpha, and those two angles, they are equal to 90 degrees. Okay, so we actually can derive from the fact that all the angles of triangle ABD congruent to all the angles of triangle DEC, that those two triangles are similar to each other. So I will write it down. We'll focus on the right triangle, triangle ABD. And the right triangle, triangle DEC. and those two triangles are equal to each other, they are both equal to alpha. So here angle ABD is equal to angle EDC, this angle, so those angles are equal to each other according to the rule that vertex angles are equal to each other. I repeat again, angle ABD equals to angle EDC according to the rule that vertex angles are equal to each other. And if angle ABD equals to alpha, from this equation alpha equals to ABD equals to EDC, we derive that angle ADC is also equals to alpha. And those two angles are also equal to each other, and they are both equal to 90 degrees once alpha. So we can write down that angle BAD this angle is equal to angle ECD, this angle, and they are both equal to 90 degrees minus alpha. Again, angle BAD equals to angle ECD, and they are both equal to 90 degrees minus alpha. And those two angles are also equal to each other, and they are both equal to 90 degrees. So angle ABD, this angle, is equal to angle DEC, this angle, and they are both equal to 90 degrees. Angle, I repeat again, angle ABD equals to angle DEC, and they are both equal to 90 degrees. So all the angles of the right triangle, triangle ABD, the right green triangle, triangle ABD, can point to all the angles of the right main triangle, triangle DEC. Therefore, we can write down that the right triangle ABD similar to the right triangle DEC according to angle similarity rule. I'll repeat again. We conclude that the right triangle ABD is similar, this is the sign of similar, to the right triangle DEC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that the following relationship exists between their sides. We conclude that AB over EC is equal to BD over DE and it is equal to AD over DC. I'll repeat again. From the fact that the two right triangles are similar to each other, we will conclude that AB over EC equals to BD over DF and it is equal to AD over DC. So AB is equal to 6 units according to what is given us in the question. EC, we already found out that EC equals to x plus y. So we substitute EC by x plus y. BD is BD. We'll find out the value of BD later. Over DE. DE equals to y according to our definition. Here. And it is equal to AD that is equal to x according to what is given as the question. Over DC. DC equals to 10 units according to what is given as the question. So in conclusion, according to equation number 1, we found out that 6 over x plus y equals to BD over y equals to x over 10. Here we will find out the value of BD by implementing the Pythagoras theorem on the right great triangle ABD. So in the right great triangle ABD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AD square equals to AB squared plus BD squared. I repeat again. In the right green triangle ABD by PT is Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD square equals to AB square plus BD square. Here AD equals to x, so AD square is x square. And it is equal to AB square. AB is 6, so AB square is 6 squared, that is 36, plus BD square. BD is a missing line segment, so we repeat it as it is. So in conclusion, we found out that x squared equals to 36 plus BD squared. Here we subtract 36 from this equation, and we get that according to this equation, BD squared equals to x squared minus 36 here we take a root out of this equation, and we get that BD is equal to the square root of x squared minus 36. Okay, so we found out the value of line segment BD. BD equals to the square root of x squared minus 36. Now you can substitute BD in this equation number 1, by square root of x squared minus 36. So we do it now, and we get that according to equation number 1, 6 over x plus y is equal to BD, and BD equals to the square root of x squared plus 36 here over y, and it is equal to x over 10. Okay, so here we have this equation number 1. Six over x plus y equals to x y minus to the square root of x y minus 36 over y, and it is equal to x over 10. From this long equation, we will derive two equations. The first equation will be that those two expressions are equal to each other. That is to say, we will derive that from equation number 1 that 6 over x plus y is equal to x over 10. Here we will cross multiply this equation number 1, and we get that according to equation number 1, 6 times 10 is 60, and 60 equals to x times x plus y. We'll open the brackets of this side of equation number 1, and we get that 60 equals to x times x is x squared plus xy. We'll subtract x squared from this equation, equation number 1, and you will get that according to equation number 1, xy is equal to 60 minus x squared. I'll repeat again. According to equation number 1, we found out that that xy equals to 60 minus x squared. In the next step, we will create equation number 2 from this expression. Those two expressions, they are equal to each other, so this will be equation number 2. It states that the square root of x squared minus 36 over y equals to x over 10. Here we will cross multiply this equation number 2, and we will get that according to equation number 2, xy equals to 10 times square root of x squared minus 36 . So we actually have two different expressions for xy. In the next step, we create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So here according to equation number 3, xy according to equation number 1 that is equal to 60 minus xy must be equal to xy according to equation number 2 that is equal to 10 times square root of x squared minus 36. Here we will square both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared equals to 10 squared is 100, and here the square root of x squared minus 46, here the square cancels the root and we left only with x squared minus 36. So in conclusion, we found out that according to equation number 3, 60 minus x squared equals to 100 times x squared minus 36. Here we will open the brackets on both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared is 60 squared, that is 3600. plus x squared, that is x to the power of 4, minus 2 times 60 times x squared, and it is equal to 100 times x squared minus 3600. So here we will add 3600 to this equation, and we will get that 3600 plus 3600 is 7200, plus x to the power of 4 minus 2 times 60 is minus 120 x squared, and it is equal to 100 x squared. Here we will subtract 100 x squared from this equation, equation number 3, and we get that according to equation number 3, x to the power of 4, and here we have minus 120 x squared minus 100 x squared, it is minus 220 x squared, plus 7200 equals to 0. So here we will substitute minus 220x squared by minus 180x squared minus 40x squared. And we get that x to the power of 4 minus 180x squared minus 40x squared plus 7200 equals to 0. We will divide this expression in equation number 3 to 2 parts. This is the first part, and this is the second part, and then we will we take a common factor from each part. From this part x squared minus 180, from this part x to the power of 4 minus 180 x squared, we will take x squared as a common factor. So x squared is a common factor. What is left from x to the power of 4 after we took from it x squared as a common factor? What is left it is actually x squared minus, here, what is left from minus 100x squared after we took from it x squared as a common factor? What is left it is actually minus 180. And from this expression, we'll take minus 40 as a common factor. So what is left from minus 40x squared after we took from it minus 40 as a common factor? What is left is actually x squared. And what is left from 7200 after we took from it minus 40 as a common factor? What is left? It is actually minus 180. Why? Because minus 180 times minus 40, it is exactly equal to 7200. And this is equal to 0. Here we will take x squared minus 180 as a common factor out of those two expressions, and we will get that So x squared minus 180 is a common factor. What is left from this expression after we took from it x squared minus 180 is a common factor? What is left? It is actually x squared. And what is left from this expression after we took from it x squared minus 180 is a common factor? What is left is actually minus 40, and it is equal to 0. So here we have this equation number 3, and from this equation we will have two solutions that are possible for x. The first solution for x is that x squared minus 180 equals to 0. And the second solution for x is that x squared minus 40 equals to 0. So according to the first solution, x squared equals to 180. Here we added 180 to this equation number 1, and we got that x squared equals to 180. We will take a root out of this equation number 1, and we get that x equals to the square root of 180. 180 is 36 times 5. So here the square root of 36 is 6. So, and inside the root we have left only 5. So in conclusion, we found out that according to the first solution for x is equals to 6 times square root of 5. That is actually equals to 13.41. That is greater than 10. This is the first solution for x. And the second solution for x is x squared minus 40 equals to 0. That is to say, x squared equals to 40. Here we take a root out of this equation number 2, and we get that according to equation number 2, x is equal to the square root of 40. And we know that 40 is 4 times 10. So we substitute 40 by 4 times 10. And we get that x equals to the square root of 4 times 10. So according to equation number 2, x equals to the square root of 4 is 2. So in conclusion, we found out that x equals to 2 times square root of 10. Two times square root of 10 is 6.32. That is less than 10. So we have here two solutions that are possible for x. The first solution is x equals to 6 times square root of 5, that is equal to 14.41, that is greater than 10 units. And the second solution for x is that x equals to 2 times square root of 10, that is equal to 6.32, that is less than 10. Okay, so in the next step, I will draw triangle ABD and triangle ADC in the new page, and we will analyze those two triangles in order to find out which solution is correct according to the drawing, because we know that in triangle ABD we have the hypotenuse that is AD equals to x, and in triangle ADC we have also side AD that is equal to x. So I'll copy triangle ABD, the right triangle ABD and triangle ADC in the new page. Here we will define this angle BAD is theta. This angle equals to alpha. So in the right great triangle, triangle ABD, in this right great triangle, triangle ABD, is ABD. In this great right triangle, triangle ABD, we have three interior angles. The three interior angles that we have in the right triangle, triangle ABD are theta, 90 degrees, and alpha. And actually, this angle, that is angle ADC, is defined as an extreme angle of triangle ABD. So angle ADC is an extreme angle of the right great triangle, triangle ABD. Of this great right triangle, triangle ABD. Okay. And we have a rule that determines the size of the external angle of a triangle. According to rule number 1, the size of an external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So I read rule number one again. According to rule number one, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So we know that angle ADC, this angle is an exterior angle of the right hand triangle, triangle ABD. And according to rule number one, the size of this interior angle, angle ADC, is equal to the sum of the two interior angles that are not adjacent to it. And here, angle alpha is adjacent to angle ADC, and the two interior angles that are not adjacent to it are angle theta and this angle that is a right angle. So, in conclusion, the size of this exterior angle, angle ADC, equals to the sum of the two interior angles that are not adjacent to it. That is to say, it will be equal to 90 degrees plus theta. Okay, because those interior angles, 90 degrees and theta, are not adjacent to it. Therefore, and the sum of those two interior angles that are not adjacent to it are 90 degrees plus theta. So in conclusion, we found out that the interior angle, angle ADC, equals to 90 degrees plus theta. And it is also given us in the question that this angle equals to 45 degrees. And we know that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle ADC must be equal to 180 degrees. So which angles we have in triangle ADC? We have this angle that is equal to 45 degrees. We have this angle that is equal to 90 degrees plus theta. And we have this angle that is actually angle, the missing angle, angle ACD. In total, the sum of those three angles must be equal to 180 degrees. Here we subtract 135 degrees from this equation, and we get that (45 degrees plus 90 degrees is 135 degrees), so it will get cancelled. So here we will have theta plus angle ACD that is equal to 180 degrees minus 135 degrees, it is 45 degrees. So here we subtract theta from this equation, and we will get that the missing angle, angle ACD, is equal to 45 degrees minus theta. Okay, we found out that the missing angle, angle ACD, the missing angle ACD equals to 45 degrees minus theta. So this angle equals to 45 degrees minus theta. And then it is very easy to see from the drawing that in triangle ADC, this angle that is equal to 45 degrees minus theta is the smallest angle. So we can write down that angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ACD. I'll repeat again. This triangle ACD, 45 degrees minus theta is the smallest angle. And we also know it is given us in the question that DC equals to 10 units. Okay, and we have also rule number 2. According to rule number 2, rule number 2 relates to the smallest angle in a triangle. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So I read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always opposite the shortest side. So according to rule number 2, this angle that is the smallest angle, we know that AD equals to X, according to what is given us the question. So here, according to rule number 2, the smallest angle in triangle ADC, that is actually this angle that is equal to 45 degrees minus theta, is located opposite the shortest side. That is to say, according to rule number 2, AD that is equal to X is the shortest side in triangle ADC. AD that is equal to X, according to rule number 2, is the shortest side. The shortest side in triangle ADC. Again, why AD that is equal to X is the shortest side? Because the smallest angle is located opposite it. Because of the fact that the smallest angle, that is 45 degrees minus theta, is located opposite side AD that is equal to x, then according to rule number 2, AD that is equal to x must be the shortest side in triangle ADC. Okay, here the smallest angle in a triangle is always opposite the shortest side. We know that this angle ACD, is the smallest angle, therefore according to rule number 2, it must be opposite the shortest side. That is to say, AD that is equal to x must be the shortest side in triangle ADC. And because of the fact that AD that is equal to x is the shortest side, it means that it's less than side DC in its length. It is less than side DC in triangle ADC. Because of the fact that AD that is equal to x is the shortest side in triangle ADC, therefore AD that is equal to x must be smaller or shorter than side DC, this side in triangle ADC, that is equal to 10 units. And from this inequality we will derive that x is less than 10 units. X is less than 10 units. And we had actually two solutions that are possible for x. The first solution is x equals to 6 times square root of 5 units, that is actually equals to 13.41, that is greater than 10. So this solution, that x is greater than 10 units, is an incorrect solution because x must be less than 10 units. So we cancel this solution and we left only with the solution that x is equal to 2 times square root of 10 units, that is actually equals to 6.32 units, that is less than 10 units. And that is the answer to the question, that the length of line segment x that is equal to AD, it is equal to 2 times square root of 10 units, or we can also present it as 6.32 units. That is the answer to the question. So we finished with the first method. In the next step, I will present to you how to find out the value of line segment AD that is equal to x according to the second method. In the second method, we will do another construction. From point D, we will draw a straight line on AC in such a way that the angle that will be created will be equal to 45 degrees. So, here, this angle, if this point is point E, then we draw the straight line from point D on AC in such a way that angle AED will be equal to 45 degrees. Again, angle AED equals to 45 degrees according to our construction. So here, we know that in front of equal angles in the triangle, there are equal sides. So here, in triangle ADE, we have two equal angles. Both those two angles are equal to 45 degrees. And according to the rule that in front of equal angles in the triangle there are equal sides, we will get that AD must be equal to DE. AD must be equal to DE because of the fact that those two sides are located in front of equal angles. Okay, AD equals to DE, but AD equals to X according to what is given as the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equals to X. DE is also equals to X, so we can write here that DE equals to X. And we also know that the sum of the angles in any triangle is equal to 180 degrees, so in triangle ADE, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in triangle ADE? We have one angle that is equal to 45 degrees. This angle is also equal to 45 degrees. And the third angle is equal to angle ADE. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here 45 degrees plus 45 degrees is 90 degrees. So we subtract 90 degrees from this equation and we will get that the missing angle, angle ADE, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle, angle ADE, the missing angle, is equal to 90 degrees. Therefore, triangle ADE is a right triangle. So here we define angle BAD, this angle as theta. So in the right triangle, triangle ABD, we have one angle that is equal to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. Because of the fact that 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the reason that this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle ABD to 180 degrees. Okay, and here we will draw from point E perpendicular on BC. So this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to our construction. We will define the touching point from point E and BC as F. So it is given us the question that triangle ABC is a right triangle. So therefore line segment BC is one side of a right triangle. Therefore it must be a straight line. So I write it down. Because of the fact that line segment BC is one side of a right triangle, it must be a straight line. So line segment BC is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC, point D. Then the sum of the angles on the upper side of the straight line BC at point D must be equal to 180 degrees. So which angles we have on the upper side of the straight line BC at point D? We have one angle that is equal to 90 degrees minus theta. We have this angle that is a right angle, is equal to 90 degrees. And we have the missing angle that is actually angle EDF. Angle EDF in total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. I repeat again, on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees minus theta plus 90 degrees plus the third angle that is angle EDF. In total, they must be equal to 180 degrees. Here, 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees in both sides of the equation, so 180 degrees will get cancelled. And we're left only with minus theta plus angle, the missing angle EOF. In total, it is actually angle EDF. In total, the sum of those two angles must be equal to 0. We will add theta to this equation, and we get that the missing angle EDF is equal to theta. So we found out that this angle, the missing angle equals to theta. So in the right triangle EFD, we have one angle that is equal to theta, so the other angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle EDF to 180 degrees. Here we will get that 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the reason that angle DEF must be equal to 90 degrees minus theta. So in the next step, we will prove that the right triangle ABD is congruent to the right triangle EDF. Those two right triangles congruent to each other. So why those two right triangles congruent to each other? Write it down. Triangle ABD and triangle DEF. We prove that those two right triangles congruent to each other. Why they congruent to each other? First of all, we have those two angles that are equal to each other. They are both equal to theta. So angle BAD is equal to angle EDF and they are both equal to theta. I repeat again. Angle BAD equals to angle EDF, and they are both equal to theta. Side AD equals to side DE, and both sides are equal to x. AD equals to DE, and they are both equal to x. I'll repeat again, AD equals to DE and they are both equal to X. And also those two angles that are also equal to each other, they are both equal to 90 degrees minus theta. So angle ADB in triangle ABD is equal to angle DEF, this angle, and they are both equal to 90 degrees minus theta. I'll repeat again, angle ADB equals to angle DEF, and they are both equal to 90 degrees minus theta. So we actually proved that the right triangle ABD, this right triangle, congruent, this is the sign of congruent to the right triangle, triangle DEF, according to angle side angle rule. Why? Because we proved that those two angles and the side that is included between those two angles, that is to say AD, in the right main triangle, triangle ABD, congruent to those two angles and the side that is included between them in triangle DEF. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. Okay, from the fact that those two right triangles congruent to each other, we conclude that AB equals to DF. AB equals to DF, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles AB and DF must be equal to each other. But AB equals to 6, according to what is given as the question. AB equals to 6. So from this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6. Okay, DF is also equals to 6 units. So here we found out that DF equals to 6 units, and what is the value of line segment FC? It is very easy to see from the drawing that FC equals to DC minus DF. I'll repeat again, DC minus DF equals to FC. Okay, FC equals to DC minus DF. So FC equals to DC, that is 10 units, minus DF, that is 6 units. So FC equals to 10 minus 6, that is 4 units. So we found out that FC equals to 4 units. Likewise, from the same reason that those two triangles congruent to each other, because of the fact that those two triangles congruent to each other, we will conclude that BD equals to EF. Okay, BD equals to EF, according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define BD as Y, if BD equals to Y according to our definition, here we can write down that BD equals to y according to our definition. So from this equation, y equals to BD equals to EF, we will derive that EF is also equals to y. EF is also equals to y. So right here that EF equals to y. Okay, so in the next step, we will prove that triangle ABC, the right big triangle, triangle ABC, is similar to the right small triangle, triangle AFC. Okay, so we'll focus on the right big triangle, triangle ABC. And the right small triangle, triangle EFC. And we will prove that those two right triangles are similar to each other. So why those two right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees. So angle ABC, this angle is triangle ABC, is equal to angle EFC, this angle in triangle EFC, and they are both equal to 90 degrees. I'll repeat again. Angle ABC equals to angle EFC, and they are both equal to 90 degrees. This angle is a common angle, it belongs both to triangle ABC and also to triangle EFC, so we can write down that angle BCA is equal to angle FCE, and they are both, it is actually, the angle equals to itself, okay? It is a common angle, it belongs to both triangles. So you can see here, this angle belongs both to triangle ABC, and this angle also belongs to triangle EFC. Therefore, the angle is equals to itself. So angle BAC equals to angle FCE. It's a common angle that belongs to both triangles. And we also have those two angles that are also equal to each other. Those two angles that are equal to each other. Those two angles are equal to each other according to third angle theorem. So angle BAC in triangle ABC is equal to angle FEC, this angle in triangle EFC, so angle BAC equals to angle FEC according to third angle theorem. So what is third angle theorem? Third angle theorem is that if you prove that two angles in one triangle congruent to two angles in another triangle, then the first pair of angles must also congruent. And we proved that those two angles in triangle ABC, the right big triangle, congruent to those two angles in triangle EFC, therefore the first pair of angles must also congruent. Why? Because they are complementary to 180 degrees. So we actually proved that all three angles in triangle ABC congruent correspondingly to all three angles in triangle EFC. Therefore, we proved that triangle ABC is similar to triangle EFC. I will write it down. We actually proved that triangle ABC is similar, this is the side of similar to triangle EFC. EFC according to angle similarity rule. Okay, and because of the fact that the triangle ABC is similar to triangle EFC, we will conclude that the following relationship exists between their sides. We will conclude that AB over BC in triangle ABC, AB over BC in triangle ABC is equal to EF over FC in triangle EFC. I repeat again. From the fact that the two triangles are similar to each other, we conclude that AB over BC equals to EF over FC. So here, AB is equal to 6 units, so we substitute AB by 6. BC equals to Y plus 10. So we substitute BC by Y plus 10. And it is equal to EF. EF equals to Y over FC. FC equals to 4 units. So in conclusion, I found out that according to equation number 1, 6 over Y plus 10 equals to Y over 4. Here we cross multiply this equation number 1, and we get that according to equation number 1, 6 times 4 is 24. 24 equals to Y times Y plus 10. Here we'll open the brackets on this side of equation number 1. And we get that according to equation number 1, 24 equals to Y times Y is Y squared plus 10Y. Here we subtract 24 from this equation number 1. And we get that according to equation number 1, Y squared plus 10Y minus 24 equals to 0. So we have here a quadratic equation and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared plus 4 times ac over 2a. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b equals to 10, and the coefficient c equals to minus 24, and the variable that we are looking for is y, so x equals to y. So we put the data inside the equation for x, and we find out the value of the values of y, because y equals to x. So we get that according to this formula, x equals to y, so y equals to minus b, b equals to 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared, that is 100, minus 4 times A is 1 and C is minus 24 over 2A. A is 1, so 2 times 1 is 2. So y equals to minus 10 plus minus 4 times minus 24 is plus 96, and 96 plus 100 is 196 over 2. The square root of 196 is 14, so y equals to minus 10 plus minus 14 over 2. So here we will have two solutions that are possible for y. The first solution, y1 equals to minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. So we found out that the first solution is y equals to minus 12. This is a negative solution. But because of the fact that y is a length of side BD, y is a length of side BD of triangle ABD, it must be a positive number. So write it here that y is a length, therefore it must be a positive number. Therefore, y can never be equal to minus 12, that is a negative number, so we'll cancel the solution, and we're left only with the second solution, that y2 equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2, so we found out that y2 equals to 2. Here, y equals to 2, so I'll copy the right triangle ABD, and we will implement the Pythagoras theorem of the right triangle ABD. Okay? According to the Pythagoras theorem of the right triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ABD, by PT is the equation for Pythagoras theorem, we will get that AD square, the square of the hypotenuse, equals to AB square plus BD square. AD is x, so AD square is x square, equals to AB square, AB is 6, so AB square is 6 squared, that's 36, plus BD square. BD is 2, so BD square is 2 squared, that is 4. So in conclusion, we found out that x squared equals to 36 plus 4, that is 40. We take out of this equation and we found out that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2, so it is 2 times root of 10. So in conclusion, we found out that x equals to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Repeat again, x equals to either 2 times square root of 10 units, or we can present it also as 6.32 units. We finished with the second method. In the next step, I will present to you how to find out the length of line segment AD that is equal to x according to the second method, according to the third method. Okay. In the third method, we will define angle BAD as theta, and we will define side BD of the right triangle ABD as y. In triangle ABD, in the right triangle ABD, we know that tangent theta equals to BD over AB BD equals to y according to our definition, AB equals to 6, so in conclusion we found out that tangent theta in the right triangle ABD is equal to y over 6. In the next step we will focus on the right triangle ABC. In the right triangle ABC, tangent theta plus 45 degrees equals to BC over AB. Tangent theta plus 45 degrees equals to BC over AB in the right triangle ABC. BC equals to y plus 10, and AB equals to 6, so in conclusion we found out that in the right triangle ABC, tangent theta plus 45 degrees equals to y plus 10 over 6. Okay, we actually have trigonometric identity for tangent theta plus 45 degrees. So I write it down. According to the trigonometric identity, we get that tangent theta plus 45 degrees equals to 1 plus tangent theta over 1 minus tangent theta. So we can substitute tangent theta plus 45 degrees in this equation number 1, by this expression. We do it now, and we get that according to equation number 1 plus tangent theta over 1 minus tangent theta equals to, according to equation number 1, it is equal to y plus 10 over 6. We have already found out that tangent theta equals to y over 6, so we substitute tangent theta in this equation number 1 by y over 6, and we get that according to equation number 1 plus tangent theta is y over 6 over 1 minus tangent theta is also y over 6, and it is equal to y plus 10 over 6. Here we will multiply 1 by 6 and then we will divide it by 6 in order to have a common factor with y over 6 and with minus y over 6, and we get that according to equation number 1, 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. So here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and we're left only with 6 plus y over 6 minus y, that is equal to y plus 10 over 6. Here we cross multiply this equation number 1, and we get that according to equation number 1, 6 times 6 plus y equals to 6 minus y times y plus 10. We'll open the brackets on both sides of this equation number 1, and we get that 6 times 6 is 36, 6 times y is 6y, it is equal to 6y, 6 times 10 is 60, minus y squared, minus 10y. Here we have 6y on both sides of the equation, so 6y will get cancelled, and we're left only with 36, that is equal to 60 minus y squared minus 10y. Here we will add 10y and also y squared to this equation number 1, and we get that according to equation number 1, y squared plus 10y plus 36 equals to 60. We subtract 60 from this equation number 1, and we get that according to equation number 1, y squared plus 10y, and 36 minus 60 is minus 24, equals to 0. This is the same quadratic equation that we have in the second method. We have already solved this quadratic equation, and we found out that this quadratic equation has two solutions. The first solution is y1 equals to minus 12, and the second solution is y2 equals to 2. But here, because of the fact that y is a length, therefore it must be a positive number. Therefore, y can never be equal to minus 12. It is a negative number. We cancel this solution, and we left only with the solution that y equals to 2. So I will copy the right triangle ABD in the new page, and we will implement the Pythagoras theorem on the right triangle ABD in order to find out the value of x, that is the hypotenuse of the right triangle ABD. So here we get that we have the right triangle ABD, BD equals to y, that is equal to 2 units, AB equals to 6, AD equals to x, so according to the Pythagoras theorem, in the right triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AD square equals to AB square plus BD square. AD is x, so AD square is x square. is equal to AB square, AB 6, so AB square is 6 squared, that is 36, plus BD square, BD is 2, so BD square is 2 squared, that is 4, so x squared equals to 36 plus 4, that is 40. Here we take out all of these equations, and we get that x equals to the square root of 40, that is actually 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Okay, in the next step, I'll summarize the lecture. Actually, we wanted to find out the value of line segment X, which is actually equal to AD. In the first method, we did a construction. We extended line segment AD by a straight line, and then from point C we drew perpendicular on the extended AD. We define the touching point between the perpendicular from C and the extended AD is point E. So this angle is a right angle according to our construction. So in the right triangle AED, we know that the sum of the angles must be equal to 180 degrees. Here, that is to say 45 degrees plus 90 degrees plus the size of this angle, that is actually angle ACE. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we found out that the missing angle ACE equals to 180 degrees minus 135 degrees, it is 45 degrees. So this angle ACE equals to 45 degrees. So in the right triangle ACE, we have two equal angles, and we know according to the rule that in front of equal angles there are equal sides, we get that side AE must be equal to side EC. We define DE as y, so AE equals to x plus y. So we got the equation that x plus y equals to AE equals to EC. From this equation, we concluded that EC is also equals to x plus y. Then we know that those two angles are equal to each other. According to the rule that vertex angles are equal to each other, so if one angle is equal to alpha, then the other angle must be also equal to alpha. So if this angle is alpha, then in the right triangle ABD, this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in the right triangle to 180 degrees. Likewise, if this angle equals to alpha in the right triangle EDC, this angle must be equal to 90 degrees minus alpha. So we actually proved that the two main right triangles are similar to each other. Why? Those two angles, they are equal to each other, they are both equal to 90 degrees minus alpha. Those two angles, they are also equal to each other, they are both equal to alpha. And those two angles, they are also equal to each other, they are both equal to 90 degrees. So we actually will conclude that all the angles in triangle ABD can go into all the angles of triangle DEC. Therefore, those two triangles are similar to each other according to angle similarity rule. And from the fact that those two angles are similar to each other, we will conclude that AB over EC equals to BD over DE, and it is equal to AD over DC. Okay? Because of the fact that the two given triangles are similar to each other, we conclude that AB over EC equals to BD over DE equals to AD over DC. Then we found out the value of line segment BD by implementing the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem, AD square equals to AB square plus BD square. AD square equals to AB square plus BD square. AD equals to X, so AD square is X square. And it is equal to AB square. AB is 6, so AB square is 6 squared, is 36, and it is equal plus BD square. We subtracted 36 from this equation, and we got that BD square equals to X squared minus 36. We took out of this equation and found out that BD equals to the square root of X squared minus 36. So now we can substitute BD by X squared by square root of X squared minus 36. We did it, and we got that this, according to this, we got the equation number 1 that states that 6 over x plus y equals to the square root of x squared minus 36 over y, that is equal to x over 10. On this long equation number 1, we created two equations. Those two sides are equal to each other, so 6 over x plus y equals to x over 10. We cross multiplied this equation, and finally we got that xy equals to 60 minus x squared. Then we created the equation number 2 from this equation. According to equation number 2, the square root of x squared minus, those two expressions are equal to each other. That is to say, square root of x squared minus 36 over y equals to x over 10. We cross multiply this equation number 2, and we got that xy equals to 10 times square root of x squared minus 36. Then we created, so this is equation number 2. We have two different expressions for xy. Then we created the equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. Xy according to equation number 1 is 60 minus x squared, and it must be equal to xy according to equation number 2, that is actually equals to 10 times square root of x squared minus 36. So we solved this equation and found out that here we have two solutions that are possible. The first solution is x squared minus 180 equals to 0. And the second solution is x squared minus 40 equals to 0. From the first solution, we got that x equals to the square root of 6 times square root of 5. That is actually 13.41, that is greater than 10 units. And the second solution for x is x equals to 2 times square root of 10 units, that is 6.32 units, that is less than 10 units. Then I go triangle ABD and triangle DAC in this new page in order to find out which one of the two solutions are correct in our drawing. Here, in the right triangle, triangle ABD, angle theta, this angle that is 90 degrees, and angle alpha are considered or defined as interior angles, and angle ADC is defined as an exterior angle. So angle ADC is an exterior angle of triangle ABD. And we have, according to rule number 1, the size of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. That is to say, the size of this interior angle equals to 90 degrees plus theta. And we know that the sum of the angles in any triangle is equal to 180 degrees. The sum of the angles in triangle ADC equals to 180 degrees. And we found out that the missing angle here, angle ACD equals to 45 degrees minus theta. And this angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay, angle ACD that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. And we have rule number 2, that the smallest angle in a triangle is always opposite the shortest side. So, this smallest angle ACD, this angle is opposite the shortest side. So that is to say, side AD that is equal to X is the shortest side of triangle ADC. AD that is equal to X is the shortest side of triangle ADC according to rule number 2. But here we know that DC equals to 10 units. AD is the shortest side, therefore AD must be less than 10 units. Okay, AD must be less than DC that is 10 units. That is to say, AD that is equal to X must be less than 10 units. And the solution that X equals to 6 times square root of 5 units, that is 13.41, that is greater than 10, is the correct solution because X must be equal to less than 10 units, and we left only with the solution that X equals to 2 times square root of 10 units, so in terms of numbers, X equals to 6.32 units. We finished with the first method. In the next step I showed you how to find out the value of line segment X according to the second method. In the second method we did another construction. From point D we do straight line on AC in such a way that angle AEC will be equal to 45 degrees. So in triangle AEC we know that we have two angles that are equal to each other. In front of equal angles in the triangle there are equal sides, that is to say AD must be equal to DE, but AD equals to X, so from this equation X equals to AD equals to DE, we will derive that DE is also equal to X. In the right triangle ADE, the sum of the angles must be equal to 180 degrees. So here the missing angle must be equal to 90 degrees. We defined this angle as theta, therefore this angle must be equal to 90 degrees minus theta. We know that triangle ABC is the right triangle, therefore BC, line segment BC is a straight line because it is one side of triangle ABC. So here BC is a straight line, and we have the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles here must be equal to 180 degrees. That is to say, 90 degrees minus theta plus 90 degrees plus the missing angle that is angle EDF, in total they must be equal to 180 degrees. We solved this equation and we found out that the missing angle EDF equals to theta. So this angle equals to theta. Then from point E we do perpendicular on BC, so this angle equals to 90 degrees. And because of the fact that in the right triangle EDF this angle equals to theta, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in triangle EDF. So 180 degrees, this angle must be equal to 90 degrees minus theta. Then we proved that those two right-hand triangles are congruent to each other according to angle side angle rule. And from the fact that those two right triangles congruent to each other, we conclude that AB equals to DF. But AB equals to 6. So from this equation 6 equals to AB equals to DF, we derive that DF is also equals to 6 units. Likewise, BD must be equal to EF because of the fact that those two right-hand triangles congruent to each other. So if BD equals to Y, then from this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. Then we know that DC minus DF equals to FC. Therefore FC will be equal to 4 units. And then we proved, therefore, then we proved that the right triangle ABC is similar to the right triangle EFC according to angle similarity rule, and from the fact that those two right triangles are similar to each other, we will conclude that AB over BC equals to EF over FC. AB equals to 6 units, BC equals to y plus 10, EF equals to y, and FC equals to 4. We solve this equation, and we got two solutions for y. The first solution is y equals to minus 12, and the second solution is y equals to 2. Y cannot be a negative number because y is a length, it must be a positive number, so the first solution that is a negative number is the incorrect solution, and we left only with the solution that y equals to 2 units. We implemented the Pythagoras theorem on the right triangle, triangle ABD, and we got that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Then I showed to you how to find out the value of line segment x according to the third method. In the third method, we defined angle BAD as theta, side BD as y. In the right triangle, triangle ABD, we know that tangle theta equals to BD over AB. BD is y, AB is 6, so tangle theta equals to y over 6. In the right triangle, triangle ABC, tangle theta plus 35 degrees equals to y plus 10 over 6. Then we have the trigonometric identity for tangle theta plus 45 degrees. It is equal to 1 plus tangle theta over 1 minus theta, or over 1 minus tangle theta. Then we substitute the tangle theta plus 45 degrees in equation number 1 by this expression y plus tangle theta over y minus tangle theta, and then according to equation number 1, it is equal to y plus 10 over 6. Then we substitute the tangle theta by 1 over 6. We solve this equation, and we got to the quadratic equation with two solutions. One, y1 equals to minus 2f, and the second is y equals to 2f. But because of the fact that y is an f, it must be a positive number. So we cancel the first solution, that is a negative number, and we left only with the solution that y equals to 2. Then we implemented the Pythagoras theorem on the right triangle, triangle ABD. The square of the hypotenuse equals to the sum of the sides of the perpendiculars, that is to say AD square equals to AB square plus BD square. AD is x, so AD square is x square. That is equal to AB square. AB is 6, so AB square is 36, plus BD square. BD is 2, so BD square is 2 square, that is 4. So x squared equals to 36 plus 4, that is 40. We took out of this equation and found out that the value of x, the variable that we are looking for, is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so the value of x is either 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. So in all three methods, we found out the same result, that x equals to either 6.32 units, or it is, you can represent it also as 2 times square root of 10 units. Okay, thank you very much.